So let me start with the first concept for today, which is on division of distinct objects into groups. Division of distinct objects into groups. Okay. Now, in order to explain this concept, I will not directly jump with a formula. It's very easy for me to give you a formula, but I would give you a situation. And depending on the situation, let us see from our prior knowledge, are we able to find out the number of ways to perform that simple activity which I'm going to discuss with you. Let us say I take an example. There are 4 students, let's say. Okay. And I want to divide them into 2 groups. Okay. So I want to segregate them into 2 groups. One should have 3 students and other should have 1 student. Okay. My question to you is, in how many ways can we do that? No, Aditya, it's not possible to start with complex numbers today because we have a lot of concepts waiting for in permutation combination. Yeah. So here is a question to everybody. There are 4 students. You have to make 2 groups out of them. One should have 3 students. Other should have 1 student. How many ways can you do that? Now, simple answer to this that would come in everybody's mind is 4C3. Correct. So if you choose the 3 students, right, the one which is left off automatically be another group, right? So the moment you're choosing something, that itself be a group, and whatever student is left off, he or she will behave as another group, correct? So the answer here would be nothing but 4C3, which is like 4 factorial, 1 factorial, 3 factorial. Am I right? Any questions here? Any questions, any concerns? Or 4C1, yes, or 4C1, or 4C1, absolutely. Okay. Now, the same experiment, now I'm performing in a slightly different way. Let us say these are different groups now. Okay. So let me say I want to divide 4 students into 2 groups, group A and group B. Okay. Such that group A and group B, they have strength of 3 and 1. Okay. So I'm dividing it into 2 groups. Okay. And one group should have a strength of 3, other group should have a strength of 1. Now, I'm not saying group B has a strength of 1. I'm saying one group should have a strength of 3, other group should have a strength of 1. How many ways will you do that? Now, here you will say, okay, there are 2 cases that come up. Case number 1, A should have 3 students and B should have 1 student. That is one way to do it. Or case number 2, A should have 1 student and B should have 3 students. Correct? So what is my question? I'm repeating my question here. You're dividing it into group A and group B such that one of the group has got 3 students and the other group has got 1 student. Correct? So how many ways? 2 ways. A should be 3, B should be 1, or A should be 1, B should be 3. Correct? Now, if A is 3, B is 1, the number of ways to do will be 4C3. Correct? Yes or no? And if I want case number 2 to happen, it will be 4C1 or 4C3 again. That means your answer will become 2 times 4C3. That means your answer will become 2 times 4 factorial by 1 factorial, 3 factorial. Okay. Or other way to look at it is, let us first segregate it and then these 2 can change their positions, right? So the same 3 people which were chosen first could be in group A and the other one in group B, or you could change the position of the groups, or you can change the position of these people in the groups. Okay. So here what happens, your answer becomes multiplied by 2, or you can say it gets multiplied by 2 factorial. It gets multiplied by 2 factorial. because you can change the same people between these two groups, isn't it? Okay. Heading of this topic is division of distinct objects into groups. Okay. Don't use those words like permutation of groups. Okay. Permutation of groups, basically you are trying to shuffle these elements within the two groups. Now here, basically I discussed with you two situations. One where order was not important. Order of the group was not important. Was not important. Or you can say the group was not distinct. You're just segregating it, right? In the first case, you're just, segregating it. You're not saying this is group A, this is group B. You're not giving any order to them, right? In the second case, order of the group is important. Yes. Okay. And let me tell you one interesting thing, which is the next experiment which I'm going to take up. Let's say you have the same four people. You want to segregate it into two groups of two people each. Okay. Okay. Let's say you're just segregating them. Order of the group is not important. Okay. Then tell me, order of the group is not important. Now, many people are still confused. What is the meaning of order of the group is not important? See, order of the group is not important means you are not assigning any kind of a name to the group. You're not assigning any kind of distinct nature to a particular group. Are you getting my point? Grouping means you are just segregating them out. You're not saying this will be group 1, this will be group 2, this will be group 3, this will be group 4. You're not giving any name to it. You're not attaching any identity to the group. Are you getting my point? Okay. So now you tell me, in this case, how many ways can you divide 4 into two groups? Now here, a small change has happened, that this time the two groups are of equal sizes. Both have two elements each. Then how many ways will you do it? What do you think is your answer? Okay, Madhav says 4C2. Okay, 4C2 means 6, correct, Madhav? Okay, now let me perform this experiment manually and see whether your result was correct or not. So let's say these four people I'm splitting up as A, B, C, D. I'm splitting it as AC, BD, and I'm splitting it as AD, BC. Okay. Is there any fourth possibility? You said 6 should be the answer. Now, let me tell you, AB, CD and CD, AB are considered to be the same because you have just split them into two groups. Okay. So the answer here is not this. The answer here is not 6. The answer here actually is 6 by 2. So your actual answer here will be 4C2 by 2 factorial. Or you can say it's 4 factorial by 2 factorial, 2 factorial, 2 factorial. Getting my point? Now the very same scenario, again I'll take one more case. See, I'm taking so many cases just to highlight the difference between these different concepts that may come to you. I'm dividing it into two groups of two people each, such that order of the group is important. Order of the group is important. Okay, so you're naming it, let's say group A and group B. Then in this case, your answer will again be 4C2 by 2 factorial into 2 factorial, because now the same two people can change hands. So now ABCD and CDAB will be considered to be different things. First, AB was a part of group A, or just say group 1. CD was a part of group 2. So let's say if CD comes into group 1 and AB goes to group 2, they will be considered to be different cases. They will be considered to be different divisions. Okay. So from these four cases, what did we learn? What did we learn? We learned something which is very, very interesting, and a lot of questions are based on this. So I would like to take a generalization of this concept. all of you, please listen to this very carefully, because this is going to be the make or break point, between your understanding and doing well in these topics and the other students. Correct? These are the topics which are not very well understood by many of the students across the country. Okay? Even I, as a student, I must admit that I struggled with these concepts. Okay? Because I was not very clear about the entire distinction. Okay? I learned it a very hard way. So I want you to understand this very, very carefully. So listen to this statement of mine. If, let us say, you have, I'm just taking an example. Let's say if you have M1 plus M2 plus M3, etc. till Mn as distinct objects. So these are your distinct objects. It could be people, it could be objects, anything you want to consider it. And you're dividing it into n groups. You're dividing it into n groups. And each of these groups have these many number of objects into them. Okay? Remember, your M1, M2, etc. they are all different values. They are all different values. ... Okay? So let me explain this scenario here. You have these many objects with you, total number, and you're dividing it into n groups, such that each group contain different number of, values in it, or different number of objects in it. So if the order is not important, if the order of the group is not important, then the total number of ways to do it would be M1 plus M2 till Mn whole factorial by M1 factorial, M2 factorial, all the way till Mn factorial. All the way till Mn factorial. Please make a note of this. A simple example I can cite for this is, let us say there is 52 playing cards. Okay, I want to split the card into, let's say, 4 groups, such that one contains 11, other contains 12, this contains 13. How many is left? 20, 23, 36 is gone. So this will contain 16. Okay. So if I say how many ways can you cut 52 cards into 4 groups, one containing 11, other containing 12, other containing 13, other containing 16. So you just have to segregate it. You're not calling 11 card group to be some, or you're not giving it to some person. You're just segregating it. Well, while playing game, you segregate the cards, no? Okay. So let's say you make 4 segregations out of it. One having 11, other having 12, other having 13. So the answer to this will be simply, if you go by your common sense approach, it will be 52C11, then 41C12, then 29C13, and then 16C16, which is actually a 1. If you simplify this, you will see 52 factorial. In fact, let me do it for you so that you understand it. This will be 11 factorial, 41 factorial. 41C12 is 41 factorial by 12 factorial, 29 factorial. 29 factorial, 29C3 will be 29 factorial by 16 factorial, 13 factorial. And this is anyways a 1. So a lot of terms will get cancelled if you see. And you'll be left with 52 factorial by 11 factorial, 12 factorial, 16 factorial, 13 factorial. That is what I have written over here in this formula. Okay. So I have not written something which comes from the sky. I've just written what I would have anyways got had I done this approach. Are you getting my point? Now, if the order of the group is important, then what happens? If the order of the group is important, then what will happen? If the order of the group is important, then what will happen? Order of the group important means, for example, the same split. For the same split, let's say you had 11 12, 13 and 16. Let's say if you gave these cards to people, let's say Ram, Shyam, Ghanshyam and let's say Abhiram is playing the game. So it would make a difference if these 11 cards went to Ram, or it went to Shyam, or it went to Ghanshyam, or it went to Parshuram, whatever, right? So the splitting is the same, but if they change hands, they would be considered to be different division. That is the meaning of order is important. Okay. So when order is important, a small change will happen to this formula. Everything will remain the same. Just in the last step, what will happen? In the last step, what will happen? Let me show you. You have to multiply it with n factorial. Because the same 4 people can change the same set of cards among themselves in 24 ways, in 4 factorial ways. Same cut of bundles, same cutting, right? What do you call is cutting, no? People who play cards and all. The same cutting of cards, you can change hands in 24 ways, isn't it? Yes or no? Okay. So you have to multiply your answer with the total number of groups factorial. Right? So the same question, if I say, in how many ways can you distribute 52 cards to 4 players, Ram, Shyam, Ghanshyam, Abhiram, such that one gets 11, other gets 12, other gets 13, and the last person and the other one, fourth one gets 16. So I'm not named anybody. I've not said Ram should get 11. I never said that. I never say Sham should get 12. No, I'm saying how many ways can you cut out a set of 52 cards into 4 such groups, 11, 12, 13, 16, and distribute it to Ram, Shyam and Ghanshyam and give it to Ram, Shyam and Ghanshyam. Here the answer would become 52 factorial by 11 factorial, 12 factorial, 13 factorial, 16 factorial into 4 factorial. Okay, so please note this is 11, my mad if I have written it like 14. Okay, is this idea clear? So this extra 4 factorial will come into picture. Now, this was a case, I'm so sorry sir, this was a case when your groups were of unequal size. Okay, so this is a case, let me write it over here. This was a case where your groups are of unequal sizes. That means no group were having the same number of object. Unequal size groups. Okay, I'm writing it in bold so that we are not getting confused. Okay. Next case, if your groups are of equal sizes or some of your groups are of equal sizes, then what will happen? Now, next thing which I'm going to take is sum of the groups, some or all also, some or all groups are of equal sizes. Are of equal sizes. See, I'm writing it in very bold alphabet so that when you're referring to your notes, you understand the distinction between them. So let us say I have m plus m plus m dot 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 k plus mk plus 1, mk plus 2, all the way till, let's say, mn. Okay. So what I have done, I have these many distinct objects with me. I have these many distinct objects with me. Please note, the reason I have written m over here because they all contain, they're all the same values, and these mk plus 1, mk plus 2, etc., they're all different. Okay. So m is not equal to mk plus 1, is not equal to mk plus 2, is not equal to mn. Okay. Now I'm dividing these into n groups such that first k of them have the same number of items. Dot 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 So these K groups are of equal size. So equal size groups. Okay. And they are K in number. And the other ones will have, let's say, MK plus 1, MK plus 2, MK plus 2. They are all unequal sizes group. These are all unequal sizes group. Okay. So these are all unequal size groups. Okay. In this case, what will happen? All of you please pay attention. If the order is not important, that means you're not assigning any identity to the groups involved, then your total number of ways would be m plus m plus m, whatever, till mk plus 1. I mean, total number of objects, so as to say, whole factorial divided by m factorial to the power of k. Basically, you are writing m factorial, m factorial, m factorial k times, divided by k factorial, because k of those will have the same number of objects into it. So you have to divide by k factorial here. And the others will go as they normally are written. Okay. So if the order is not important, then total number of objects factorial divided by factorial of these equal sizes groups multiplied to themselves k times, that means m factorial to the power k, and an additional term will come over here. This is very important. 99% people forget this, dividing by k factorial. So the number of groups which are having the same number of items, you have to divide it by the k factorial. Now many people will ask me, sir, what if there were equal number of items in 3 other groups? Like say 2 of them have 2, 5 of them have, let's say, 3, 7 of them have, let's say, 7, like that. So then you have to divide by those many factorials, as I'll show you in the example. Let's say same 52 cards, I'm splitting up into groups of 11, 11, and let's say 15, 15. Okay. How many ways can you split this up into groups of 11, 11, 15, 15? Now you can see 2 groups here are identical, 2 groups here are identical. So the answer here would be 52 factorial by 11 factorial square and 2 factorial, because these two had equal number of items. Again 15 factorial square and again divided by 2 factorial, because these two had equal number of items. Are you getting my point? Okay, so I'll give you one more example. Let's say there are 100 objects, 100 distinct objects. You are making, let's say, 3 groups of 10, 10, 10. Okay, let's say making 4 groups of 5, 5, 5. Okay, how many? I think 50 is already taken up into consideration. And let's say one group of 25 and one group of 12, another group of 13. Okay, so I think it's coming out to be 50, 100, check, 30, 20, 50, 50 plus 50, yes. Okay, so how will you do this? If the order is not important, that means you're not assigning any name to the group, or you're not considering them to be different groups. So your answer would be 100 factorial by 10 factorial cube, and you have to divide by 3 factorial, because there are 3 groups which are containing the same number of items. Then 5 factorial to the power 4, you have to also divide by 4 factorial, because 4 of them are containing equal number of items. And then 25 factorial, 12 factorial, 13 factorial. That's it. Is this clear? So I think with these 2 examples, it would be very clear to you how does the division here happen. Okay. Now, if you were assigning it to some people, or let's say order became important, if the order is important, then what will be the change in your answer? No, not much of a change. Everything will be going as per the, per the previous case. Just you have to do one extra thing. You have to multiply by the factorial of the total number of people, or total number of groups. So everything is same. I'm just copy pasting the above part. I'm not writing anything extra here. One step extra is you have to multiply with the total number of groups factorial. Total number of groups. Okay, so count how many total groups are there, multiply with the factorial. This is when the order is important. Okay, so let's say I give you a small question. Let's say 52 cards you are splitting up as 12, 14, and 14. Okay, not much can be done. 14, and you're giving it, this split you are distributing between 4 players: Ram, Shyam, Ghanshyam, and Abhiram. How many ways can you split it? So then your answer will be 52 factorial by 12 factorial square, 2 factorial because 2 of them had equal number of items, 14 factorial square, again 2 factorial because 2 of them had 14, and then multiply with 4 factorial because the same set of cards can interchange hands in 4 factorial ways. Are you getting my point? Is this clear? Okay. Any questions? Yes, Madhav. Same thing I have written, but I have to divide by the factorial of the total number of objects. That is what you are saying, no? How do you write it in the form of NCR, right? The previous formula only. See, why did you divide that 4C2 by 2 factorial? You only said 6 and then you realize, no, the answer is 3. Why did you divide it by 2 factorial? Because when the size is same and the order of the group doesn't matter, it doesn't matter whether you see the difference in the number of object itself will create a distinction. But since the item number are same, it doesn't matter whether you're splitting it as ABCD or CDAB. Are you getting my point? Okay, so that is not going to make a difference. Hence, your answer gets reduced by k factorial times. That is the reason, Madhav, why we are dividing it by k factorial. Yeah, now you got it. Okay, let's have questions. I think questions are the best way to learn these concepts. So my first question to all of you would be, in how many ways can 12 different balls be divided into 2 boys, one receiving 5 and the other receiving 7 balls? Let us do the first part. Then we'll come to the second part of the question. Guys, there are some people who are joining very late. Okay. Despite dropping the message and asking you to note the time, people are dropping very late. Don't blame me if you don't understand the concepts today. Okay. I've always said it's better to leave 5 minutes early from the class, but never join 5 minutes late. Because it's like a movie, right? You can leave a movie theater after, let's say, just 15, 20 minutes before the movie ends, because you know what's going to happen. Ultimately, happy bonding will happen or the villain will be killed. But if you don't come in the movie theater on time, you will not even understand what's going on. Okay. So I can see 5 of you have joined in late. Okay. How many ways can 12 different balls be divided into 2 boys, one receiving 5 and other receiving 7? Now, is it a case of unequal size group or equal size groups? Unequal size, Hariyan. Very good. Is it a case where order is important or order is not important? Order is important. Very good. Excellent. So now you got your answer. So if you're dividing it to two people, one having 5 and other having 7, and the order is important. Order is important means this 7 can go to, let's say, Ram, this 5 can go to Sham, or the same 5 can go to Ram and the same 7 can go to Sham. It will be considered to be two different divisions. So in such cases, as we had already discussed, it is 5 factorial by 7 factorial, 5 factorial, and since order is important, you have to multiply by 2 factorial. Okay, no need to calculate it. Don't waste your time calculating it. Second part of the question, let us try to attack. In how many ways can these 12 balls be divided into groups of 5, 4, and 3 balls respectively? Now, equal size group or unequal size groups? Unequal, correct? Order is important or order is not important? Order is not important, absolutely. Okay, Aditya has a question. Equal size of the group, why are you multiplying by n factorial? See, again, as I told you, when you split up the things, okay, when you split up the things, the same split, if it changes hands, it would be counted as a different arrangement. Let's say I'm giving you an example. Let's say there are 4 books, A, B, C, D. Okay, A, B, C, D. Now, if I choose 2 books out of it, right? If I choose 2 books out of it, I'll get 6, correct? But if I choose C and D also out of it, it'll also give me 6, but they are both counted to be the same. And therefore, I have to divide my answer with 2. But let's say this A, B book I give to Ram. This C, D book I give to Ghansham. This will be considered to be different than giving this to Ram and giving this to Ghansham. So you have to multiply your answer back with 2 factorial here, even though the size is equal. Are you getting my point? So there's no overcounting happening. No, why will there be an overcounting? Ram getting A, B, Ram getting C, D, they're different cases, no? They're different divisions. Correct? Yeah. In this case, your answer will just become 4 factorial by 5 factorial, 4 factorial, 3 factorial. Don't multiply with 3 factorial because I'm not saying that I'm giving these to people or I'm assigning these to 3 different children. Okay. So here you're just segregating it. Okay. Let's take another one. Let's take another one. In how many ways can 16 different books be distributed among 3 students A, B, C so that B gets 1 more than A, C gets 2 more than B? Let's see who gets this right. So 16 books, A, B, and C. Okay. So let's say X book is given to A, then B should get 1 more than A, and C must get 2 more than B. Okay. So you can see that since the total number of books are fixed, that is 16, that is 3x plus 4 is equal to 16, 3x is equal to 12, so x is equal to 4. Correct. So A should get 4 books, B should get 5 books, and C should get around 7 books. Okay. So what will your answer be? What will your answer be? Now, some of you are saying the answer would be 16 factorial by 4 factorial, 5 factorial, 7 factorial into 3 factorial. This is wrong answer. Sir, why? Sir, you only told, sir, order is important here, 3 people. Why not into 3 factorial? Yes, there will not be any 3 factorial here because these books are not free to change hands. Yes, they are predetermined. A must get 4. A cannot get 5 books. When do you multiply with 3 factorial? When you are saying you're distributing these books to 3 people. So you don't know who will get 4, who will get 5, who will get 6. So there is an arrangement possible of 6 ways. But this is predetermined number of books. A should get 4 only, B should get 5 only, and C should get 7 only. You cannot shuffle the same 5, 7 and 4 books among these 3. No, that would be wrong then. So you have to stop here and this would be your answer. Guys, this is what many people will make mistakes because they would have rectified the answer. They don't know from which logic those formulas come out. So you should always know the logic behind these formulas. Don't try to just know the formula only. It is not going to help you in competitive exams, especially of national level like JEE Main and JEE Advanced. Is this fine? So this question was an eye opener. So if the same groups are, or the same group items can change hands, or let's say if you start naming these groups or assigning these groups to different people, then you multiply by the factorial of the total number of groups. Else you will not. Okay. Let's take another one. Let's take another one. In how many ways can 9 different books be distributed among 3 students if each receives at least 2 books? If each receives at least 2 books. Now, don't type out the answer, just say done so that I know you are done with the concept. Okay, then we'll discuss and then see where you went wrong. Nine different books divided among 3 students, each receiving at least 2 books. Very good. Okay. So here, the following cases can be built up. Since you want 2, 2, 2 to go to everybody, I can have 2, 2, and 5. That's one possibility. Okay. Or I could have 2, 3, and 4. That's another possibility. Or I could have 3, 3, and 3. Okay. So this is how I'm distributing it to 3 students. Now, of course, you can, order is important over here, so you can change hands. But prima facie, these are the distribution that is possible. I don't think so any other distribution is possible. Okay. Now, let me call this as case 1, case 2, and case 3. Let us look into case 1. How many ways can you split 9 books to 3 people such that 2 of the groups have equal number of items and the third one has a different one? So your answer would be so simple. It would be 9 factorial by 2 factorial square into 2 factorial into 5 factorial, and since order is important, into 3 factorial. Because now these books can change hands also. I never said this 2 books should go to Mr. A, this another 2 books should go to Mr. B, 5 should go to C. I never said that. So they can exchange hands. Okay. This is 9 factorial, 2 factorial, 3 factorial, 4 factorial, again into 3 factorial. Thankfully, this is unequal size group case. And the third one will be 9 factorial by 3 factorial cube divided by 3 factorial into 3 factorial. Okay. So you add these 3 answers and that would give you the final result for this. Okay, I'm not calculating it in the interest of time, because as I told you, we have a lot of things to cover in today's chapter. Okay, very good, Charan. Any questions here, anybody? Any questions here, anybody? Okay, next concept that we are going to talk about is division of n distinct objects into r distinct groups. Okay, now many of you would be wondering, sir, isn't it a case where you are trying to distribute n distinct objects into r different groups? I mean, r groups where order is important. So why are we studying this concept separately? Isn't it included in the previous concept? You're absolutely right when you think so. There's no problem in your thought process, that this is as good as saying that you are trying to split n distinct objects into r different groups. Okay, but the difference between the previous concept and this concept would be here, the group sizes are not predetermined as it used to be in our previous few cases or few examples that we took. So this is something which I'm taking in more generic way. Okay, of course, whatever you took so far is a subset of this, but this is in more generic way, right? So here you'll see a lot of variation, a lot of varieties. Okay, let us try to discuss this. So let me take a scenario for the same. Let's say you have O1, O2, O3 as n distinct objects. Okay, and let's say there are R boxes, box 1, box 2, box 3, till box R. Okay, as you can see here, these all boxes are named, hence they are distinct boxes. Okay, so you can say the order is important now. The order of the group is important, right? Now my question is, in how many ways can you distribute these n balls into these R boxes such that blank box is allowed? Blank box, or you can call it as group, is allowed. Okay, how can you do this? Now the answer to this is pretty simple. Don't overthink. If you overthink, you will not be able to get it. How many ways can you distribute these n balls? Now, each box is of infinite capacity. So more than one ball can definitely, in fact, all the balls you can put it in the one box also. It is so big. Each box is so big that it can accommodate any number of objects or balls, whatever you want to call it, into it. Okay, so Pooja says n to the power r. Okay, anybody? Anybody who thinks differently? Madhav says r to the power n. Okay, so two contestants have already given their answers. R to the power n, n to the power r. Who is correct? Now here, each ball is a chooser. Each object is a chooser. O1 can choose any one of the R box to which it wants to go. Okay, so this has got R options. O2 can also choose any one of the R box it wants to go. O3 can also choose any one of the R box. So like that, you are writing R n number of times. So Madhav is correct. Answer is R to the power n. Now this is the same mistake that you were making in the very first class of permutation combination. Remember, I asked you one question of letter boxes and letters. Okay. Raghuram, I mean, it's okay. You had some technical issues. That is fine. I cannot debate against that. But we are into such a stage where you may find difficulty to understand. So, okay, I'll be there to help you in case you want any. Okay. So, any doubt regarding this? Any doubt regarding this? Okay. Now, the second case is slightly tricky. What if blank groups are not allowed? Blank group is not allowed. Blank group is not allowed. That means every ball should, or every box should contain at least one ball into it. How will you solve this question? Now, all of you, please pay attention. This is slightly tricky. Now, some of you would be saying, sir, I would make cases. Yes, of course, you can make cases if your number of balls and objects are small. Correct? You can definitely make cases. You can definitely make cases. I'm not denying it. And you should make cases actually. Because whatever I'm going to derive next is a slightly lengthy and tedious to remember formula. So all of you, please pay attention. Let us say I call an event B1 where box 1 is blank. Blank means empty. There is no object into that box. Okay. Just listen to me. At the end of this discussion, you'll definitely make sense of what I'm talking. So let's say B1 is an event where you are saying box 1 is blank. Okay. Tell me. Yeah, Pranav, if you're doing that, Pranav, then which ball are you going to add to which group? Are you getting my point? Okay, that would be also, into accounted for, isn't it? So that will complicate the scenario quite a lot. Then you may have equal sizes group, you may have unequal sizes group. All those things will make this process. See, if you know the value of R and if you know the value of N, and they are quite small values, then making cases is not an issue at all. Okay. In fact, I also solve questions by making cases only. But this formula is also very important, which I'm deriving right now, because it is going to be used in your functions chapter also. We'll see when you come to class 12. Okay. So all of you, please listen to this. Let's say B1 is an event, or let's say B1 is a set where I'm trying to put all those cases where box B1 is blank. Okay. Right. Now tell me, if box B1 is blank, how many ways can I distribute these n objects to the remaining r minus 1 boxes? Now, I'm not trying to say that other box may not be blank. Other boxes may or may not be blank. That is not my concern. My concern is B1 is pakka blank. Then how many ways can you distribute the walls or objects? So you will say, sir, simple. It is like each of these n objects will have r minus 1 choices. So you'll have r minus 1 to the power n. Correct? Now, in this r minus 1 to the power n, there may be boxes other than B1 which are blank, which I'm not denying that. Okay? But B1 is pakka blank. That is what I'm trying to say. Don't try to take this case as if I'm trying to say only B1 is blank. No, I'm not saying only B1 is blank. I'm saying B1 is blank. Others may or may not be blank, which I don't care. Okay. Why I'm taking this case, you will understand in some time. Just have a bit of patience. Okay. Let's say B2 is an event where box B2 is blank. What is the total number of ways it can happen? You'll say, sir, same. It will be r minus 1 to the power n. Correct? Can I say that will be the same even if I had, let's say, taken BR as the event where box BR is blank? Okay. So the total number of cases will be r minus 1 to the power n. Correct? Okay. Now in the similar line, I will take B1 intersection B2. See, I'm speaking the language of sets over here. B1 intersection B2 means you want box B1 and box B2 to be blank. Okay. Can you tell me how many ways can this happen? Now, others may or may not be blank. Others may or may not be blank. Please watch out my words. So you'll say, okay, only B1, B2 is not allowed to carry any balls with it or any objects with it. So I can distribute these n objects into r minus 2 boxes. So it'll be r minus 2 to the power n. Absolutely. So without waste of time, can I directly conclude that if I claim that any two box Bj and Bi, okay, are blank, then the number of ways to do that would be r minus 2 to the power n. Okay. And similarly, I'm not going to waste a lot of time over here. if I want any three boxes, let's say BI, BJ and BK to be blank, it will be R minus 3 to the power n, and so on and so on. Correct? Now I'll make sense of whatever I have written so far. All of you please pay attention. I'll just write on top of it. Okay. What do I need? I need, in how many ways can I put these distinct objects into these R boxes such that no box is blank? That is what I need. That means I need the number of ways in which B1 is not blank, or box 1 is not blank, and box 2 is not blank, and box 3 is not blank, till box R is not blank. Basically, I need the cardinal number of the intersection of the complement of these sets. See, earlier I started with B1 is the event where box B1 is blank. B2 is the event that box B2 is blank. B3 is the event that box B3 is blank, and so on. But actually, what do I need? I need those cases where these boxes are not blank. Correct. So I need complement of these cases. So I'm basically talking in the language of sets with you. Now, as per the De Morgan's law, this is as good as n B1 union B2 union B3 up till BR whole complement. This is the De Morgan's law. Correct. Let me write it down over here also. Let me just remove my camera for some time. Yeah, this is by De Morgan's law. De Morgan's law. Correct. So something complement means universal set. Let me write it like this: total number of elements in the universal set minus the total number of elements in the union of these sets. Correct. Okay. Now, as per the formula that you have learned, this can be written as NB1, NB2, and so on till NBR minus intersection 2 at a time. Okay. 2 at a time means it can be any 2 at a time. I cannot write everything because it's beyond my scope to write everything. Then plus intersection 3 at a time. Correct. Dot, 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 like that. Okay. In short, basically, you can write it as number of elements in the universal set minus summation of NBI minus summation of NBI intersection J, BJ, plus summation of BI intersection BJ intersection BK. So basically what I'm doing, I'm using an advanced version of the formula that you have learned in your sets chapter. So people who are wondering, how am I writing these things? I would like you to recall one of the formulas. I think I have spaced down over here. Please recall this formula. You had done this formula in your sets chapter. NA union B union C. What was the formula for this? It was actually NA, NB, NC minus NA intersection B, NB intersection C, NC intersection A plus NA intersection B intersection C. This was the formula. The same thing I'm writing in a more specific way. So if you have more than 3 sets, let's say A1, A2, da 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 till let's say AN, this term can be written as summation of NAI. The same terms that you have written over here can be written as minus summation of NA1 or NII intersection AJ, and so on and so forth. That is what I have written over here. Okay. Now let us fill in these values. What is the number of universal set? What is the number in the universal set? That means how many ways can you distribute these objects to these R distinct boxes with no restriction? With no restriction. You will say, sir, R to the power n. That's what we had discussed when there were blank groups allowed. Okay. Minus NBI is basically, or you are saying summation NBI is like you are basically adding R minus 1 to the power n R times. So you can write it as RC1 R minus 1 to the power n. That means this term BI can be chosen from those R boxes in RC one way. And if that box is supposed to be empty, then the other box can be filled in R minus 1 to the power n way. So that one box which you are choosing to be empty itself can be chosen in RC one way. That's why RC1 times R minus 1 to the power n. Okay. Similarly, the two boxes which you are choosing over here, you want to be empty itself can be chosen in RC2 ways, and the remaining can be filled in this way. Similarly, the three boxes which you want to be empty can be chosen in RC3 way, and the remaining boxes can be filled in this way. So like that, a chain will continue till wherever it goes, till wherever it is giving you non-zero values. The moment it starts becoming zero, you have to stop there. So this is a huge formula which comes out from this exercise. Basically, this is what we call as the principle of inclusion and exclusion. So this has come from this principle, which is called the principle of inclusion and exclusion, which itself is this formula that you have learned in your sets chapter. This itself is called principle of inclusion and exclusion. Let me write it down. Principle of inclusion and exclusion. Okay. Now, do we have to remember this formula? I never remembered it when I was preparing for JEE. I actually solved it by my concept of division into groups that we learned prior to this. Okay. I'll show you a simple example where I will demonstrate that without using the formula and with using the formula, you get the same answer. Okay. So let's take a small question. The question is, anybody wants to copy this? Could you go up for a second? Up for a second means this part. Okay, this is something which you need to note down. So I'm writing note next to it. Done? Okay. Just took a screenshot. That's good, actually. All right. So let me take a question on this. All right. Let's have this question. In how many ways can 5 different balls be distributed into 3 boxes so that no box remains empty? Now, this is for me to solve. All of you, please watch. If I use formula, using formula, okay, then remember, n here is 5, r here is 3, and there's no box empty. So basically, it's the second case what we discussed a little while ago. So as per the formula, your answer should be r to the power n minus rc1 r minus 1 to the power n minus rc2 r minus 2 to the power n plus rc3 r minus 3 to the power n minus rc4 r minus 4 to the power n wherever it allows it to go. Okay, so r is 3, n is 5. So if I use the formula, I'll end up getting this. Okay, I think at this point of time, I'll start getting 0. So I don't have to proceed any further. So let me stop it over here. Okay, so this will become 243 minus 3 times 2 to the power 5. 2 to the power 5 is 32. Minus 3 times, I should write 5 over here. Why I wrote n, I don't know. Anyways, okay, into 1. Okay, so this will give you 243 minus 96 minus 3, which is 243 minus 93. That's actually 150 ways. Correct? Now, let us say you had a bad day and you forgot this formula. That doesn't mean you cannot solve the question. Okay? You can still solve the question if you make cases. Now see, without formula way to solve it. Now, you have to distribute 5 into 3 boxes such that no box is empty. So you can have like 1, 2, 2. That's one way. Or you could have 1, 1, 3, right? Of course, since boxes are different, they can change their hands. That is something which I'll account for a little later on. But do you agree with that these will be the 2 divisions possible? Any other division possible? I don't think so. I cannot have 2, 2, 2. I cannot have 1, 1, 2. Okay. Okay. Now, this case, as we have already seen our division into groups concept, it will be 5 factorial by 1 factorial by 2 factorial square and further by 2 factorial, because you have 2 groups of equal sizes. And since these blocks are distinct, they can change hands in 3 factorial ways. That means you can have 1, 2, 2, you can have 2, 1, 2, you can have 2, 2, 1, like that kind of a scenario. Here also, this can be 5 factorial by 1 factorial, 1 factorial, or you can say 1 factorial square, and by 2 factorial, because 2 groups are of identical sizes, just like here, these 2 were of identical sizes, by 3 factorial, and into 3 factorial because they can change hands. Okay, let's calculate this. So my answer will be this plus this. Okay, this gives me 120 by 448 into 6. This gives me 120 by 2. So we all know that 120 by 8 is 15. So 15 into 6 will be 90, and this will be 60. So your answer will be 90 plus 60, 150. So the same thing which I had got by the use of formula over here, I got it without the use of a formula. So there's absolutely no need for you to remember that formula. So then why did you teach us that? See, I want you to be prepared for the worst scenario. There may be cases where that formula may directly be asked to you in some or the other form, and you should be aware of it. Does it make sense? Does this make sense? That is what, Aditya, that is what the problem is. That will create too many cases. That will create too many cases. And that may also create overcounting also sometimes. Okay. Wow, Vaibhav, could you show the question? Full Ramayana is over and now you are asking who was Ram? Madhav, sir, will the formula hold if the question was each box had at least two books? Yes, yes. No, no, no. See, again, when you had at least 2 books, the best way is to go by cases. But even that, in that case, your situation should be easy enough to handle. It cannot be applied to, very complicated cases. Are you getting my point? Okay. So you can have different versions of the question. But the problem is, are those versions manageable by making cases? It's not that I did not solve this question by making cases. I solved this question by making cases only. But there are some instances where the number of cases will be too many. And the question will also be such that it cannot be solved by making cases. Try to understand. See, nobody is going to ask you out of the world question. Okay. But whatever question they're going to ask you should be well solved by the number of cases you're going to form. Let's say the same question. If I say there are 50 books, okay, and there are 36 boxes, how many ways can you do it? Could you solve that question by making these 2 cases? No, probably. Correct? But such a question will never arise, because if they give such question, they know half the people are going to waste time making these cases. So these kind of formula that time helps you a lot. But from my experience, I've seen that JEE will never give you such a scenario where you cannot solve it by making cases. Or if, let's say, cases cannot be made, there must be a way out, alternative way out. Okay. Next concept that we are going to talk about is a very resonating concept. Name is very similar. arrangement.